Hi everybody and welcome to EUMeTrain weather briefing for today. I'm Aniina Korpinen from Finnish Meteorological Institute and today I'm on behalf of Petri Pyykkä, who is usually our guy who is keeping these weather briefs. But today you have me. And as mentioned previously, we have only me. Pyry is not able to come today and present what was planned for his status. But I think we will manage only with me today. So, this is first time me participating in this EUMeTrain weather brief, so some information about me. I have been working in FMI more or less 6 years now. As for the weather forecaster, I have started working only last autumn, so autumn 21st. I started working as weather forecaster. So in the way, this is quite new to me, and it's my first spring actually to do this weather forecasting. So exciting times. Currently I'm also working as a meteorological expert. I do develop these kind of post-processing methods. So I do at least plan is to combine different kind of observation with the model and then do this kind of application to ease forecasting the weather. And I have previously worked as a researcher and then a software developer. My work mainly has been related to validation of numerical weather prediction models. I have working with mostly with the clouds and then the boundary layer, and then just trying to find out how well the model actually produce or is simulating those features. And also I'm quite interested in within the data science, and I'm really excited to study the subject and find the ways to make the data science applications to help weather forecasting and make application from those. Okay, for today's topics, first we start as usual do this weather briefing of the current weather, so what is going on currently in the Europe. And I have a couple of slides of the coming up weather, so something to forecast only for tomorrow and day after that. And then because I had the extra time for today, I'm presenting or mentioning you about this kind of satellite nowcasting method to create a total cloudiness application for model and forecasting. But I actually watched some of the videos, how you usually do this presentation. And there was this really fun feature that you can actually mark your current place where you are currently or where you are from. So let's give you right to do this. So can you now write something? Now you should all be able to place your marks. So where you are from? I'm from here. Actually from Helsinki, but in general in Finland. So all kind of places, mostly a bit more south than where I am from, and then maybe more eastern part. Interesting. It's really nice to see where you are all from. Yes, thank you. I will now remove your marks and then stop this drawing opportunity for you. Thank you all from drawing your positions or places. Okay, so let's start this checking of the current weather. I'm not that familiar actually within the satellite products, so I'm presenting you what I'm usually actually do what. So within the making the forecast, I usually check this more or less a visible light product. where we can estimate the clouds and the height of the cloud. So within these yellow areas, we have more low-level clouds, so we have a liquid droplets there. And within these more blue areas, we actually have ice particles there, so it estimates that it should be more higher level clouds. And actually in these areas, we can see that the cloud is actually quite thick. I hope that you actually can see my mouse on this.
Yes, we can see it. Yeah.
Yeah, really good. Because otherwise it would be quite pointless to say that in this place. Well, so we can actually see that almost most of Europe there is like no clouds at all. With the lack of this product is of course that if we have snow like we have in here, it's really similar to low level clouds. And especially in this area, it's really hard to estimate, is this ice or snow, or is it like small clouds? I assume that in Italy it is actually cloud, but this could be more like snow. But if I'm wrong, you can say that it's not that way. The cloudiest part what we have in Europe currently are in Scandinavia, where we have a lot in Iceland, and then in UK, Ireland, and Spain has all kind of things going on over there. And then the eastern part also there is this kind of like a convection going on there. But the situation in Europe is quite calm currently. With now we have the 500 hectopascal height also in here, so we can see that we have the upper level low in this Belarus area. Otherwise, we have quite strong high pressure areas, and then we have this like zonal movements going on in northern part of Europe. And of course, this what happened in Spain is also more or less causes this lower pressure area in high levels, same as in Turkey. I usually also watch this kind of like more infrared channel product where we can see different temperatures with different color. So this and there we can trying to make a difference between the snow and then higher level clouds or lower level clouds. And we can see that this is quite red. And that's 4, we can assume that this actually is snow. And then we have the lower level clouds, which are more like white or blue. And then we have also some higher level clouds, which are more orange. And that's why I also assume that this would be more like something snowy over here. And actually we can see in this sea area near Finland that there is actually ice over the sea, and there is a nice line between the clear sky and the clouds where we can see that there is low level clouds, and then we have the ice here. And of course we can see in Russia that there is snow on the ground. Yeah, but the most events what currently is going on happens in the Spain, and then Turkey and Scandinavia, and then this kind of like northern Atlantic. And we can compare this also with this higher level pressure or height, and we can quite nicely see this upper level low what we have here. Yeah, let's move on. Okay, now we have the water vapor channel, so we can see the moisture. The more dark the picture is, the more dry basically the air is. And we can see that where we have the high pressure area, the air is also quite dry. It is the driest part what we have in Europe. And then we have, as mentioned before, in Spain, quite a lot of moisture in there, also in Scandinavia, and there we can see some structures that might estimate yet to be, but currently in the Europe, the jets are not that easy to locate from the water vapor channel. The high pressure area in Central Europe is quite large and strong, and it's pushing the main flow away from Central Europe to southern and northern parts or northern roads. With this, we have also this water vapor channel confined to 500 hectopascal height. And if we also check the jet from the model, we can see that the strongest jets are in the northern part of Europe. And it's not, as mentioned before, so easy now with the water vapor channel to see the jets. Of course, this is just like model. It's not the perfect estimation of observations. Combination is a bit hard to do, but I think the gray lines are quite the same and the way it should be. Yeah, so in the north we have the strongest jet. Also in Spain, the flow is coming from the Africa side. And then what we have in Turkey, it's coming probably from the Siberia. So easter, maybe drier, colder air. Here we have the air mass product from the satellite. What you actually can see here is more like it's the air mass temperature is cold or warm. The most of the Europe is quite warm currently, and then it's more clear in the eastern part of the Europe that it's in here quite cold, the air. In Turkey, the air should be actually quite cold also, but a bit more moist. And this kind of feature you can spot from this product. And in Spain, the air is actually quite moist also, but quite warm also. So I think the current situation in Europe, we have quite a strong temperature gradient. I also took from European Central Mid-Range Weather Forecast Center, took this 850 hectopascal temperature. So we can see air mass temperature in the way that the surface is not affecting the temperature itself. So the purely how temperature is from the air. And we can see as same way as the previous slides that most of Europe is quite warm, where the high pressure area is. Then we have this upper level low, which is producing the colder air in here. Also in Turkey, we have colder air. And then in Spain, we actually have really warm air coming from the Africa. And while we go to the opposite side of this picture, northern part of Europe has really cold air mass. I have also mean sea level pressure in these pressure areas. So we can see that this mean level high pressure area is really strong in the Europe. It has been over 3 weeks, I guess almost 1 month already. But in general, the change is coming from that. Now, as I mentioned, there is this brief forecasting of tomorrow's and day after weather conditions in Europe. This high pressure area, which is in Central Europe or western part of Europe, is not getting any weaker in a couple of days. Some changes might come next week, but we are not concentrating that now. So in this area, from south to east, the high pressure is actually really strong, which is forcing the movement from the North Atlantic to northern road. So in Scandinavia, we have an event coming tomorrow, and also I actually not really sure what is the causing this kind of raining in this Spain area. I think it's probably good to mention you now at this state at this colored area here present the raining area. So we have precipitation coming in these areas. We have the wind arrows also, and then this is the mean sea level pressure in the lines. And the darker area estimate there to be cloud. So it's like total cloudiness. This is tomorrow, Friday, 25th, 12 UTC. What is this describing? So in Scandinavia, we have this, actually in this state, this has this low pressure, has two centrals. So it's developing on Friday in Scandinavia, and it's actually will probably low that much that it will be quite strong storm. So winds will be really strong after this or after side of this low pressure area. There's going to be in eastern part of the Turkey, there's going to be also raining, and in this area in general there is this kind of raining events. This in Black Sea area. If we check the air mass temperature of the same time as the previous slide was, we can see that this colder area is actually coming much souther than it was today's air mass temperature from the EC. At the same time, we have a really strong, really warm air in the western part of the Europe, so we have quite strong temperature gradient from the South Europe to Northern Europe. And we have this cold air mass, which has been in the same place almost 2 weeks at least. Not as time to time a bit colder, what is now, but quite cold air is still flowing from the Siberia to this area. Now we have the Saturday, 26th of March, 12 UTC time. We can see that this now this low pressure area is actually transformed into quite a strong storm. We have really low pressure here. The high pressure area in the west part has been remaining as it is, but in the eastern part it actually moved a bit more to the east. So we have this like a more unstable air in the northern part of Europe, but in the central is still quite stable. That this has been for a couple of weeks already. In this behind of the low pressure area, there is really strong wind speed coming up, maybe also for Sweden, or in this state you already probably had been, but in Finland and Estonia and the Baltic countries, the wind speed will be quite strong during Saturday. And because of this, high pressure area, which has been quite stable there in the central western part of the Europe, the Iceland has got all low pressure activities during 1 month. So there's been a lot of raining, and it's still going to remain the same way. And if we check how the air mass movement is going to happen, so this coldest air from the north is actually flowing much souther, and it currently occurs to be the way that the eastern part of the Europe is going to be quite cold. So it's getting more cold air mass, and at the same time, the Western Europe still remains quite warm. So there is the big difference between temperature, also between West and East in Europe, if this behavior continues. But currently, it seems to be that way it's going to continue. Okay. Then the last part of this presentation, I will tell you something of my current work as a meteorological expert working with this post-process tools. I have currently using this EUMeTrain SAF product, and there is one specific product, this effective cloudiness, which I'm trying to improve so we can in FMI use it for our forecasting. Just small general stuff. This is like product family of this kind of like cloud product. It combines different model variables from EC, and then satellite data, and then this radiative transfer model calculations. And from there, it actually assumes or estimates the cloud the best possible way it can do it. So the main goal for this EUMeTrain SAF product is to improve or support the nowcasting applications. So people could use those for the nowcasting. And as I mentioned, my job there is to improve this total cloudness product for the first 4 hours of the forecast. And then it's going to be from that, after that, it's going to be from the model. It's not perfect yet. There is some lacks of this effective cloudiness. The biggest one are the low-level clouds. It underestimates the low-level clouds and fogs, especially during the night when we have the high pressure area affecting and if the wind speed it's that way that it's producing cloud during the night, so then it's not getting the lower level cloud at all actually. With the high level cloud, it's not that big harm, but it also underestimates and overestimates those, but it's not that big issue for the forecasting point of view. There's also some issues with the areas of lakes and sea, if there's ice or no ice. So it's usually produced or estimates there to be cloud or low level clouds, even it's clear sky, but there is ice. And of course, in Finland, because we are really north, we have some issues with the satellite angle. We don't get the best quality data. And it's in this product, it's causing strange holes in the clouds, which is in reality there is no any holes at all. And of course, as mentioned, we are really north, so in Finland, the winter time is quite tricky also because we don't have that much light, and we need to use different channels to estimate the cloud. I have been working with this product from the January, and it most of the time it is working quite nicely. But when it doesn't work that well, I have been trying to test to combine the effective cloudiness in itself with the mesoscale model relative humidity profiles and add or remove clouds is necessary, but still that it's really in the first state, this kind of like testing and developing. But here you can see what it actually looks like. So in the left side, we have this effective cloudiness itself. And in the middle, we have this product which I have been developing to improve this. And in here, I actually didn't mention that I also use this cloud top brightness temperature to estimate or create this kind of really good cloud mask, but it's actually, as you can see, not working that well, especially in this area. You can see that it's assumed there not to be any cloud or only little cloud, but actually this affected cloudiness, maybe because of the model or radiation transfer calculations, it actually gets quite nicely clouds also in here. But as I mentioned, these weird holes, there are these usually in the area where we have a lower or thicker cloud, and after it we have low level clouds, then it's for some reason assuming that there is not cloud at all, or making these weird holes, which actually my current system is cleaning away. And we can also see that there is this kind of like a boundary of the data from satellite which we get, but we have still a cloud there. So this is purely from the model, this area, because we can't actually see anything there that much. But we actually do have some estimation of the brightness temperature also during that area, or in that area. But this is actually quite good case, even though we don't get these all higher level clouds, we get the most of the lower level clouds, which is the main feature to affect the temperature or surface features in the weather. And then we have this case where we don't have that, we actually don't have the affecting cloudiness, but my system is using some older cloudiness, which is found for somewhere, but now it's overestimating cloud in the eastern side of this map. And it's also assumed that there is actually cloud in here, which is only the ice. And there is also or underestimation of the low level clouds in here, where it actually should have some cloud. There is some, but it's not at large area than it should be. But if you want to know more about this whole product family, you can read from this document more about it and what can it offer for you. Okay, that was all from me. Actually, I took quite a lot of time, but now you can ask anything, or we can have the discussion now.